Hello, calculus fans! Graphing and visualizing three-dimensional objects can be difficult. So what we'll do is we'll leverage things that we know about two-dimensional graphs, which we know quite a lot about. What we're going to do is take cross-sections, and these are known as traces. For example, let's keep x fixed. We'll do that by setting x to be some constant, and then we let y vary. So x is a constant, y is a variable. Then we get a function of one variable. Z is equal to f of ky. K is fixed, y is a variable. So geometrically, what we're doing is we're taking the plane x equals k and intersecting it with the surface to see what we get. In a similar way, we can intersect our surface with y equals k and look at the function z equals f of x comma k. And then the last thing we'll do is we'll slice with horizontal planes z equals k to get curves f of x comma y equals k. All of these traces will help us to draw the curves. All right, as an example, let's use traces to sketch a graph of f of xy equals 4x squared plus y squared. And what I'd like to do is just talk about the traces here, and we'll actually draw a graph in class. All right, so the equation of the graph is z equals 4x squared plus y squared. So the first thing we'll do is we'll put in x equals k, just a constant. Then we'll get z equals y squared plus 4k squared. I just move things around a little bit. Notice that this thing right here, that's just a number because k is just a number. So we'll think of y as the independent variable, and in that case, these are parabolas that open up. So y is independent, z is the dependent variable, k is just a number. And similarly, if we put in y equals k, then we'll get z equals 4x squared plus k squared. These are also upward opening parabolas. And then the last thing is, if we put in z equals k, we'll get horizontal traces 4x squared plus y squared equals k. These are ellipses. The larger the value of k, the longer or wider the ellipses are. And we're going to sketch this graph later. This thing is called an elliptic paraboloid. So a paraboloid is sort of a three-dimensional analog of a parabola. An elliptic parabola is when you elongate it in one direction. Okay, that's all for now.